Welcome to our last lesson on properties of exponents, and this lesson is going to cover negative and zero exponents. This is going to introduce where these ideas come from, and this is where I mentioned a couple of videos back about how the definition of exponents kind of falls apart. We're going to use it to get to where we need to go, but if you kind of jump in part way, you'll find yourself thinking, what on earth, how is this an exponent? And then we'll do some pretty basic practice problems with just the negative and zero exponents, and then we'll jump ahead a little bit and do some of the more complex exponents simplification problems that you might see. So this lesson might be a little bit longer. So what I want to establish is what a negative exponent is and where it comes from, because it's not like it comes out of the blue where a math teacher just tells you, oh, like this is a negative exponent and this is what it means. It should derive from someplace where you're familiar. So I want to go back to this property here, and this is why I did these lessons out of order, okay? We know that if we divide like bases, we can subtract exponents, and we would subtract the denominator exponent from the numerator exponent there. And so what I'm going to do is work two problems. I'm going to work two problems using established algebraic methods. So I'm not going to pull anything out that's new. And we're going to end up in two different places. But if we do everything correctly, then the two different places that we end up must be equal to each other. So here's the example problem that I'm going to work with. I'm going to do x to the fifth over x to the, not x to the fifth, x to the third over x to the fifth. Okay, now going with the definition of exponents, stuff that we know, stuff that we're familiar with. We know that x to the third is x times x times x. We know that x to the fifth means that x is used as a factor 5 times. Now, I am going to add one little thing in here that's probably going to seem weird, but it'll make sense in a moment. Hopefully you will agree that I could put a times 1 in my numerator. It might seem a little weird for me to put a times 1 in there, like, okay, like, sure, whatever, but hopefully you can agree that we can put a times 1 there. Now, using the same reasoning that we used in the last lesson, I know that anything divided by itself is 1. And so essentially what we have here is 1 times 1 times 1. And then what we're left with is an x times x. Now, the reason I put that times 1 in the numerator is because when I'll ask students, okay, what's left over in the numerator? If I just go ahead and cancel everything out, students stare at me. Funny. And they're like, there's nothing left. But there is something left, and the something is a 1. So while it seems a little weird to put that 1 in, it is important to be able to have that visual. So if you cancel everything out of the numerator, what you're left with is a 1. It's not like the numerator goes away or you have a 0 there or something. It's a times 1. And so we're left with a 1 in the numerator. And in the denominator, we have x times x, which is x squared. So it's kind of like we subtracted the exponents, but we ended up with the exponent in the denominator, which seems a little weird, but that's very algebraically sound. We're engaging the definition. We're multiplying by 1, all stuff that we know is okay to do. And so we end up with this 1 over x squared. Now I'm going to take the same problem and I'm going to engage this property here, which in the last lesson we established works. This is also a reliable method to use. So we take the numerator and subtract the denominator exponent from it, and 3 minus 5 is negative 2. And what should be true is if both of these methods are algebraically sound, then x to the negative 2 has to be equal to 1 over x squared. Like those have to be the same expression. And so if you think about the definition of an exponent and you think, how can something be used as a factor negative 2 times? Like, doesn't make sense. That's what I meant with the definition kind of falls apart, because how do you multiply, how do you use something as a factor negative times? So we have to kind of go into another mode there and approach it from a different angle. So x to the negative 2, if you're wondering, well, what does that mean? That means 1 over x squared. So just so you can see that that's not an anomaly, suppose we have x squared over x to the 6th. Okay, so that would be x times x, and then we would have 6x's in the denominator there. We have that weird little like, hey, remember, you could multiply that by 1. It's weird, but you could, and it wouldn't change it at all. And then look for the things that cancel out. And now we can see that we are left with a 1 in the numerator and then 4 x's in the denominator. Going the other way, where we would subtract the exponents, gives us x to the negative 4th. And so once again, we're in that situation where as long as both of these methods are algebraically sound, then they have to be equivalent. And so x to the negative 4th has to be the same as 1 over x to the 4th. So from that, we can generalize this, that a negative exponent essentially means that it is a reciprocal. Now, I actually don't like, if you've had a math teacher tell you like, oh, a negative exponent means it's in the denominator, like, yes-ish, but it doesn't really address, well, what happens if the negative exponent already is in the denominator. And that I feel is a little bit more of an Algebra 2 level skill where we might want to tackle that. So I'll try to avoid giving you any practice problems that have the negative exponent in the denominator. It's not difficult. It's just something that needs to be demonstrated so that you don't feel like you're playing algebra voodoo. And you want to understand how you handle that. Again, it's not difficult, but it's something that can wait in an Algebra 1 class. In fact, I don't think I dealt with negative exponents at all until I got to Algebra 2. So for now, the way you want to picture this is a negative exponent means reciprocal. And really try to home in on that word and not in the denominator, because in the denominator is too narrow and it's not going to handle it if the negative exponent's in the denominator, but reciprocal will handle that. So the definition is broad enough. Okay, second thing to look at, and this will be really, really quick, is what about an exponent of 0? So most students would look at 3 to the 0 and your instinct probably says, oh, that's got to be 0. But it's not. And so if you don't believe me, pause the video right now, grab your calculator and put in 3 to the 0 power. Okay, as long as you know how to use your exponent keys and you don't do it some other weird way, it's not going to tell you 0. And you might also ask yourself, well, how can something be used as a factor 0 times? If it's used as a factor 0 times, then it must not be there at all. It has to be 0, but it's not 0. So let's go figure that out. Let's reason this out so that what it is makes sense to you. So let's start with 3 to the 4th power over 3 to the 4th power. Doing the same thing. 3 to the 4th power is 3 times 3, and well, you get the idea, okay? And this is what? 81 over 81, which is equal to 1, okay? And you can probably get there from here. Anything divided by itself has to be equal to 1. That's what it is. It's the whole thing. Like, understand your fractions there. So that has to be equal to 1. Now, we also know from our study of exponents and that property right there, that as long as we are dividing like bases, we can subtract the exponents. And so I could do, that's supposed to be 4, do 3 to the 4 minus 4, and now you can see where that 0 is coming from. 4 minus 4 is 0. And again, as long as both of these processes are algebraically sound, and they are, these have to be equal. Like, they have to be. So 3 to the 0 is equal to 1. And hopefully if you did take me up on that a few minutes ago and you paused the video and grabbed your calculator did tell you that 3 to the 0 was equal to 1. So if you're a little concerned, you're like, well, great, it works for 3, but what about some generic number? What about a? We'll do a to the 5th over a to the 5th. Well, that's a used as a factor. And again, notice that we are coming back to the definition of exponent. So these properties, like something to the 0 power equals 1, it's not some magical fact that a teacher just tells you and you're supposed to remember it. It comes from the math, it comes from the definitions, and it comes from the processes that we already know. So looking at this, we have a whole bunch of 1s, which means that that has to be equal to 1. Anything divided by itself is 1. But we also know that if we divide like bases, we can subtract exponents. And so this is actually the last little property, which is anything except 0, little disclaimer in there, raised to the 0 power is equal to 1. When I was in high school, I was on the math team, and we were kind of sad, but one of the things that like math competition-y problems that people would like to do to you is they'll like to do something like this, and then throw in a fraction in there. Like that's an algebra 2 thing. Like, what do you mean a fraction? Like, what is that? Oh, I don't know. Let's make the exponent a decimal. Let's put in something that nobody's ever seen before. Sure. Okay. Like, I don't even know what I'm doing. And then what they do is outside, they'd say, oh, all of that to the 0 power equal to 1, because anything except for 0 raised to the 0 power is 1. And so even if there's a whole bunch of stuff inside that parenthesis that you might not recognize at all, math is consistent. The principles hold true. The exponent of 0 means that the whole shebang is equal to 1. So that's pretty much negative and 0 exponents. And I prefer to teach that after I cover this property here, because it really helps you to see why these properties work. So that's pretty much everything. Let me do some examples. I'm going to skip to the yucky ones. I'm going to do some yucky ones. I'll do 1 or 2 yucky ones for you. So let's take a look at this one. We'll do 16. I cannot see. The light in this room is kind of terrible. Hopefully, if I copy it wrong, I don't copy it wrong in a way that means that I can't do the problem. Accidentally do. Write myself an impossible problem. Okay. All right, so this has got some stuff going on. This is a nice problem here. So remember, and there's more than one way you can do this. One of the things I love about teaching this is that I can have 30 students in a classroom and see 30 different ways, like 30 different orders of the way that people will do this. So some people might choose to simplify this over here by canceling out the x's, and they'll simplify this and they'll do 16 divided by -4 and get -4. Some people will multiply going across and then they'll simplify. Both of those would work equally well. Some people like me, like I don't like subtracting the exponent. So once I teach that rule and use it to derive negative exponents and 0 exponents, I almost never touch it again because I just don't like it. So I just reason my way through the problems other ways. So for the sake of picking a strategy, I'm going to go ahead and just multiply across and then simplify. So I'm going to do 16 times -2, which is going to give me -32. X to the 3rd times x, which is x to the 4th. And then y times y, which is y squared. Going across the bottom, -4 times negative, and remember that there's a 1 there. So -4 times -1 gives me a +4. X times x is x squared, and then we just have the y to the 3rd. -32 divided by 4 is -8, and that's a regular -8, so it's not in the denominator. And then I mentioned after I teach the subtraction rule, I don't use it. So the way I do this is a glimpse into how I reason it out. I say there are 4 x's in the numerator, there are 2 x's in the denominator. So in my head, I'm doing this. I'm not writing it out, but I'm doing this. After I cancel them out, I have 2 x's left over, and the 2 leftover x's are in the numerator. And then I do the same thing with the y's. I say I've got 2 y's in the numerator and 3 in the denominator. After I cancel them out, I have 1 y, and that 1 y is in the denominator. So I typically will not mess around with any subtraction of the exponents after that first lesson there. Okay, let's do one more. Oh, this looks great. X to the negative 2 y squared. These are actually legit pretty awful problems. And I kind of wish that I had, you know what? I told you guys I wasn't going to do anything with the negative in the denominator, so we'll hold off on that one. Let's do, I don't know. Let's do this one. 4x y to the third over 2y times 5x y to the negative third over x squared. All right, so what do I want to do? I'm going to do this one differently, not because I prefer it. In fact, I actually think I might not prefer doing it differently, but I think I'm just going to do it a different way just for the sake of illustrating that there is more than one way to do it. So for this one, instead of multiplying first and then simplifying, which is what I did over here, I multiplied first and then simplified. On this one, I'm going to simplify and then multiply, and then you might have to simplify again. So 4 divided by 2 is 2. I have an x, that x is in the numerator, that's going to stay in the numerator. And then this is that thought process. I have 3 y's in the numerator, 1 y in the denominator. And after I cancel them out, I'm going to be left with 2 y's, and they are going to be in the numerator. So what happens there is that my denominator actually completely canceled out. So maybe that's good news. Over on this side, I have 5. That doesn't do anything. In the numerator, I have 1x. In my denominator, I have 2 x's. I'm over here on the right. I'm going to cancel those out, and I'm going to be left with 1x in the denominator. And then I have the y to the negative third, which we know is 1 over y to the third. So essentially what that does is it's going to bump the y to the third in the denominator. Now let's go ahead and multiply them. So 2 times 5 is 10, and then we're going to have the xy squared. And then 1 times the denominator there would be xy to the third. Now we actually have to go through that simplification process again. So the 10 doesn't have anything it can cancel with, so I guess that's fine. X over x, those will cancel out. So those cancel out. And then I kind of ran out of space for my scratch work, so hopefully me just saying it is good enough. I have 2 y's in the numerator, 3 y's in the denominator. I'm going to cancel some of them out, and I have 1 extra y, and that 1 extra y is in the denominator. If you cancel out everything in the denominator, you're good to go. You don't have to write it anymore because the denominator would be 1. Just remember that in the event you cancel everything out in the numerator, that you do have to have a 1 in the numerator because you cannot just bump your denominator into your numerator. So that completes the lesson. I'm going to give you some practice problems, and I will try to steer you away from the negatives in the denominator. If you're taking Algebra 1 and you have a teacher that is going to give you problems with negative exponents in the denominator, feel free to write a comment, and I will actually try to respond and answer any questions that you might have with that. But typically negative exponents in the denominator, that's something that I would illustrate and then expect my students to manipulate when they were in Algebra 2. So there's like room to grow in your exponent skills in Algebra 2. Okay, here goes. Again, this is just in case my handwriting is horrible. So x to the negative 9th, 6x to the negative 5th, y to the negative 4th, 5y all to the negative 2. So there is a negative right there. Okay, there should be like a negative 2. You can kind of see it there. Number 4 is negative 9 x to the 5th y to the 7th over x squared y to the 3rd times 2xy all squared over negative 6 x squared y squared. 5 is 3x all to the negative 2 over 6x to the 3rd. 6 is 8x to the 5th y over 4x to the 5th y squared. And number 7 is 2x all squared times 3x all to the negative 3. Pause the video, work the problems out on your own, and then unpause to check your work. Okay, let's go over this. And as always, pause wherever you need to pause in the review to make corrections to your own work or to make any supplemental notes or just to rewind to hear an explanation again. So for the first one is really just a straight application of the rule. So x to the negative 9th is 1 over x to the positive 9. So it's really just assessing whether or not you understand that a negative exponent means that it would be a positive exponent in the denominator, or in this case, like a reciprocal, like just it's the reciprocal of whatever is there. Second one, what students will often do wrong on this is they'll apply the negative exponent to something it doesn't go to. So it's really important to note that the negative 5 is only attached to the x, not the 6. And the negative 4 is only attached to the y and not the 6. So the things that have, the factors that have the negative exponents, those are the ones that move into the denominator, but not anything that has a positive exponent, which really the 6 does. It's got a positive 1. There. So the 6 is going to stay in the numerator, and then the x and the y go to the denominator where the 5 and the 4 become positive. So that would be 6 over x to the 5th, y to the 4th. So I do see that a lot where students will move something that doesn't actually have a negative exponent attached to it. For the next one, we've got 5y all to the negative 2. And so it is another application of that, of like what's done in number 1. So it's 1 over 5y to the positive 2. But then you can apply some of your other properties. So 5 squared is 25. And then, of course, you have the y squared. So the final answer would be 1 over 25y squared. Some of you might say 5 squared y squared. And again, that's up to you or your teacher if your teacher has specific directions for that. Next one. Now, before you freak out, what I would do if I were grading these is look to the final answer. So if you have 6x to the 3rd, y to the 4th, assuming I did not make some mistake in here, then probably your work is fine. Remember what I said about there's lots of ways that you can show the work. There's not just one process or one order of steps. So your steps might look very different from mine, but there is only one correct simplified answer here. So you know what I did. Here's what I did. And I don't always do these the same way myself. So I will bounce back and forth between different ways of doing it, depending on what the problem looks like and what I think the best way is. So over here on this left part here, I have x to the 5th over x squared. So again, like 5 x's in the numerator, 2 in the denominator, cancel them out. What do I have left over? I have 3 x's left over, and the leftovers are in the numerator. So that's where the x to the 3rd comes from. And then I did the same thing with the y's. 7 y's on the top, 3 y's on the bottom, cancel some of them out. I've got 4 y's left over, and they're going to be in the numerator. And you don't have to put the denominator of 1. You are left with a denominator of 1, but you don't need to write it if it's the denominator. The only time you need to write it is if it's the numerator. Then over here, I applied the exponent to all of the factors. So 2 squared is where the 4 came from, and then I have x squared, y squared. And then I just copied down the denominator. So I was like, okay, I'm not doing anything with that. And then I noticed this. X squared over x squared and y squared over y squared. Those are equal to 1. And so those cancel out. Which made this a lot nicer. Then I multiplied. Negative 9 times 4 is negative 36. So I have negative 36 x squared y to the 4th in the numerator. And then the only thing I have left in the denominator there is the negative 6. And then negative 36 divided by negative 6 is positive 6. And again, once you cancel everything out in the denominator, it's okay to leave it as 1. So my final answer was 6x to the 3rd, y to the 4th. You could have gotten there doing I wouldn't say totally different things, but you could have multiplied across the bottom and got -6 x to the fourth y to the fifth. Okay, and you'll notice that doesn't appear here anywhere, and you could have like -36 x to the ninth y to the, not, are they both 9? You know, it doesn't even matter. I shouldn't try to do it in my head. But yeah, you can get there different ways and then simplify it. So don't freak out if your work doesn't look like mine, unless you have a different answer, in which case you need to find out what went wrong in your work. This one, how did I do this one? This in the numerator is raised to a -2, and so I moved that. So here's what I'm doing there. So we've got 3x to the -2. That's 1 over 3x squared. So that's where the 1 came from. And then what happens is the 3x all squared appears in my denominator along with the 6x to the third that was already there. 3 squared is 9, and of course then you have the x squared. 6 times 9 is 54, x to the third times x squared is x to the fifth. So my final answer was 1 over 54 x to the fifth. This one here, now this is a great example of the fact that a lot of times you don't need to show any work for these. So 8 over 4 is 2. Make sure that you are dividing there. So like 8 over 4 means 8 divided by 4, which is 2. What happens a lot of times is students get so used, sorry, a cat just decided to crawl on me. Get so used to subtracting the exponents that they start to subtract the coefficients as well. But please remember that the fraction bar is division, and the only reason you're subtracting is because they are exponents. So 8 divided by 4 is 2, just a regular 2, so not like a 2 in the denominator or anything. X to the fifth over x to the fifth cancels out, and then you have y over y squared. So when you cancel out the common y's, you're left with 1y left over, and it is in the denominator there. So not all of these require work. The work doesn't always look the same. It's really about finding a method that you're comfortable with. Last one, I actually worked out 2 different ways to illustrate this. So the final answer is 4 over 27x. If that's where you landed, then yay. In the first one, I applied the exponents to everything in the parentheses. So I did 2 squared to get the 4, and then we have the x squared. Then we have 3 to the -3 times x to the -3. So it's not distribution, but it looks like it. We're just applying the exponent to everything in the parentheses. Then I kind of regrouped them. I did 4 times 3 to the -3, and then x squared times x to the -3. Well, remember that's going to be 2 plus -3, which is where the -1 comes from. Then I took the things that had the negative exponents and moved them to the denominator, not the 4. 4 doesn't move because it doesn't have a negative exponent. So the 4 stays in the numerator, and then we have 3 to the third times x to the first, which is just x, and then 3 to the third is 27. So we have 4 over 27x. This method, I opted to deal with the negative exponent first. And so I said, okay, well, 3x to the -3, that is the same as 3x to the +3 if I put it in the denominator there. Then I went and applied the exponent to everything. So we have the 4 and then the x squared, 3 to the third is 27, and then we have the x to the third. 4 over 27, that stays the same, and then we have x squared over x to the third. If you cancel them out, you've got 1x left over, and it would be in the denominator. That is an extra slide that I opened by mistake. So I wanted to illustrate that sometimes some ways of doing the problems is significantly better than another way in terms of how hairy it can get. Everybody kind of has their personal style though. I generally don't like negative exponents unless I'm in a calculus class where they come in really handy. So I tend to avoid them. I tend not to subtract exponents, but that is to some extent my personal style for how I solve the problems. Yours doesn't necessarily have to look the same way. So hopefully this helped, and this is actually everything that we're going to cover for exponents in our Algebra 1 unit.